Today we're going to talk about climate. So what determines the climate? Well, climate are weather conditions in an area over a long period of time, which is different from weather in that that's a daily change in pattern, meaning Monday it might rain, Tuesday it might be sunny. Climate's looking at maybe seasonal periods, like at least 3 or more months at a time. They look at in spring in Georgia, it's generally between these temperatures, okay? Factors that determine the climate are focused on temperature and precipitation. So temperature is going to be what it says. In our country, we use Fahrenheit, but each area is going to have its own temperature range. Does that mean it cannot be warmer or colder than that range? Of course not. It's just the average, kind of like when you talk about math, you're looking at a period of time and you're looking at all the temperatures and the ranges over that period of time. Okay, then we know that certain organisms, such as plants and animals, thrive within that range. Example, in Georgia, we do not have polar bears. Why? Because our temperature range is very warm and polar bears need very cold climates. Same to be said of places like Alaska. They are not going to have the same animals that we have here, such as maybe, I don't know, say gray squirrels. They may not have gray squirrels because they live in a warmer environment. Okay, precipitation is the area is going to have an average precipitation, same as temperature. Doesn't mean it cannot be more than that or less than that over the course of time, but it has an average, again, looking at long periods of time and often multiple years. So, small amounts throughout the year may occur in some places, larger amounts may only occur in a few places. An example of this would be places like Georgia, they have rain throughout the year. We do have wetter months and drier months, but we get rain all the time. Places over in Southeast Asia, they have what's known as the monsoonal season, meaning most of their rain comes in a short amount of time and only a few months. Those monsoonal seasons are the time that it monsoons or it rains in very large quantities. Again, just like temperature, this will play a factor in deciding what types of plants and animals live there and how long your growing season is. So if you're a farmer, you definitely need to know about this because it's going to determine things like what kind of crops you're going to plant and how long they're going to have to be in the ground before you can take them out. All right, kind of review here. Latitude determines the amount of energy an area gets from the sun. Again, always remembering the direct rays are going to fall in the areas that are mostly tropical all year round. Of course, sometimes, depending on if you're tilted away or from, towards here or way down here, that will also play a role. But again, equator areas in the middle of the earth always get some type of direct ray. So areas receiving those direct rays, the less angle will get the most solar energy, keeping it the warmest longer. The equator obviously is always going to get more energy and the poles are always going to get less. Such as in this one, we notice that it's summer here in the northern season, in the northern hemispheres, so it's summer. Down here it's going to be winter. Because of that, they will have 24 hours of darkness and we will have 24 hours of daylight. All right, so the sun, the water cycle, and the wind are also going to be factors. Review here. The water cycle's energy from the sun causing the evaporation, which contributes to the water cycle, where the water goes from the ocean to the air to the back to the land and then through runoff processes. And then wind is the sun's energy warms the surface unevenly, and so that produces winds. Remember, we have two types of wind. We have local winds that are the sea and land breezes, as well as the mountain and valley breezes, as well as global winds, which are the unequal heating of the entire earth and not just the local area. All right, topography. So something can be said about topography. Topography is the lay of the land, whether it's mountainous, whether it's flat, whether it's hilly, etc. So flat plains are often very windy. That's why a lot of places out in the Midwest, such as Texas, Oklahoma, they're very flat. They're great breeding grounds for tornadoes because tornadoes like flat environments. They also like unstable air, and those areas happen to get that as well. But it's very windy in those places, and so the wind just blows across the surface because nothing's blocking it. Often if you have mountains, you get what's called the rain shadow effect. And this is a picture right here of the rain shadow effect. And basically what happens is you have rain from expansion and cooling. Notice that the mountain kind of blocks it off. So one side of the mountain is going to get a lot of rain, and it's going to be very moist. It's going to be very happy in the sense of thriving with plant and animal life. The opposite side of that's going to get dry air because of the evaporation from the compressing and the warming. And so basically what happens is it's a rain shadow effect, meaning the shadow falls on one side, which keeps it pretty much like a desert. A lot of mountainous regions see this because the mountain peaks are very high and it kind of blocks off and stalls out that weather. Elevation influences temperature because in the troposphere, you already know that the further up you go in elevation, the lower your temperature gets. So as I go up the mountain, temperature gets cooler. That's why a lot of our mountains in the United States and all over the world are covered in what? Snow. All right, climate and large bodies of water. Large bodies of water help keep land temperatures steady. Things like the oceans, things like the giant like Hudson Bay. Okay, water heats up and cools down slower than the land does. We've already talked about that. And so water that does do those things keeps the land stable, and it allows it to have constant temperatures instead of large temperature swings. So there are two types of currents that often play roles with these. We have warm currents that influences the air by making places warmer than normal based on their latitude. And then we have cold weather currents that basically do the same. They bring in colder air, so they're going to be cooler than normal. All right, so this is an example. You have Hopedale and Stornoway. This is in the United Kingdom. This is in Canada. We have the Gulf Stream bringing waters from the tropics up through into the North Atlantic Drift, bringing with it this entire region being warmer than normal compared to its peers over here in Canada. Then you have the Labrador Current that's bringing the cold waters down from the poles, which help to secure the cold temperatures that Canada would see. All right, so there are three major climate zones, and everywhere on Earth falls between these zones somehow. You have the temperate zone, which means your warm months are generally greater than 64 degrees and your cold months are a little bit less than 50. They're going to be located between the tropic and the polar zone. And they do have cooler temperatures than the tropical zone because, again, tropics means it's warm pretty much all year round. A lot of North America falls in the temperate zone. All right, the second zone is the polar zone. You can see it highlighted here on the picture in green. So all of Antarctica, northern Russia, Greenland, most of Canada, and of course our state of Alaska. And these are going to be latitudes of 66.5 degrees and up or higher. Or in this case, 66.5 degrees and lower because you're going to be looking at the South Pole. Normally in these places, temperatures do not get above 50 degrees in their warmest months. So their summer months, we're talking not above 50 degrees. And sometimes they don't even get barely above freezing. Obviously, things like polar bears are going to thrive in this type of environment. And then the last climate zone is the tropical zone. And that's obviously going to be the highest temperatures, obviously located near the equator between the Tropic of Cancer and the Tropic of Capricorn in this region right here. Most of your temperatures are going to always be constantly above 64 degrees. A lot of times you'll have grasslands, savannas, rainforests, deserts. So you have very tropical and then you have very arid. Kind of these lookings right here. This is a savanna. I'm sorry, this is a rainforest. This is a savanna / grassland. And so both of these are contrast, but you find them equally in the same type of environment because this one's going to be warm and moist. This one's going to be dry and arid. All right. So my AC students only, you need to learn about El Nino and La Nina. So El Nino and La Nina both can lead to droughts and flooding. It's very important to understand. El Nino and La Nina mean the boy and the girl in Spanish, often brought to my attention. So when we're talking about El Nino, we're talking about when ocean temperatures are higher than usual in the tropical Pacific. So we're looking at the mid part of the Pacific Ocean. When those waters get really warm, you have an El Nino year. And basically it makes some areas cooler and wetter than normal, and it makes some areas warmer and drier than normal. So it completely changes the climate pattern that would normally be what would happen, and it does bring with it lots of areas to see problems, situations basically, which is what it's talking about when it says droughts and flooding. So warm and dry up here, but wet down here. Well, normally Southern California is not a very wet area, so oftentimes when you have an El Nino year, they get ample plus more than ample amounts of rain, and when that occurs, it often leads to things like landslides, mudslides, etc., problems. La Nina is the very opposite of El Nino, and it's when the ocean temperatures are cooler than normal. And again, we're talking about the equatorial Pacific. All El Nino and La Ninas focused only in the Pacific Ocean. And that's when you have cooler than normal. And again, you have the same kind of situations where areas that are normally warm and dry become wet and cool, and it leads to the droughts and the flooding as well.